Welcome to another session of Pythagoras and trigonometry. Today we'll be looking at solving problems using Pythagoras' theorem. Let's take example 3 and let's look at that question and try to solve it. Well, it says here a plane leaves Manchester Airport heading due east. It flies 160 kilometers before returning due north. It then flies a further 280 kilometers and lands. What is the distance of return flight if the plane flies straight back to Manchester? Alright, so the first thing we need to establish is the first point. Well, the plane starts from Manchester, so let's read the first, we'll read it line after line. So the first line is it leaves Manchester Airport. So let's say this is Manchester Airport here. So let's call Manchester Airport M. It says it flies due east. Well, in navigation, we have north that way, we have east this way. So surely it'll be flying in this direction. Okay, so that's the direction it's flying. Due east. And it flies, it says, the next line says it flies for 160 kilometers. So this is 160 km. Then it goes north. So let's say it stops here and then turns north. North is upwards. That's north. North it flies 280 kilometers and then lands. So it lands someplace here. So this is 280 kilometers. Okay, so we've worked out this bit as well. Now it says, what is the distance? The question answer is, what is the distance of the return flight if the plane flies straight back to Manchester Airport? So we're trying to find this distance here. If it goes straight back to Manchester Airport, obviously you can see straight away that it looks like a right angle triangle. So because if it's going north here, that makes this angle here a right angle triangle. So you can see from just reading line by line and doing exactly what it's saying, you can see that you can solve this problem. Well, from Pythagoras' theorem, we know that we can name this x. So let's call this bit x here. So x squared, which is the distance we're trying to look for, equals 160 kilometers squared plus 280 kilometers squared. So if we plug that into our calculator, 160 kilometers squared is 25,600 plus 280 kilometers squared gives us 78,400 kilometers squared. Alright, if we add these two together, we have 104,000 kilometers squared. So to find x on its own, we take the square root of 104,000 kilometers squared. X is, if you plug that into your calculator, you should have 322 kilometer to 3 significant figures. Okay. Example 4. Example 4 has to do with isosceles triangles. So we have these two sides. It says calculate the area of the triangle. We have these two sides which are equal. So that makes them isosceles triangle. So that means these two angles here, they're also equal. So x, x. To find the area of this triangle, we have to use Pythagoras' theorem. What that means is we can split this triangle here into two to find the height of the triangle. So we draw a perpendicular line from the top to the bottom, so that becomes 90 degrees. So that means if we pull out half of the triangle, we would have something that looks like this. So this is still 7.5 centimeter. Now we need to find the height, which is that perpendicular line that we drew. Well, because we've split this into two, the bottom also splits into two, so this here would be 3 centimeter. So let's label this A, midpoint, and C. Okay. Well, you can see straight away this is Pythagoras as well for finding the shorter side. So, and that formula is 7.5 centimeter squared. 7.5 squared equals h squared plus 3 squared. 7.5 squared gives me 56.25 equals h squared plus 9 squared. 9. Alright, let's rearrange to make h the subject of the formula. So we take 9 away from both sides. We have 56.25 take away 9 equals h squared. Alright, so 56.25 take away 9 gives me 47.25 equals h squared. So to find h on its own, I take the square root of both sides, then I put a square root sign there, 7.25 equals h. So h equals 66.87 centimeter. That's what my height is. Now, the area of a triangle is half the base times the perpendicular height. So we know what the height is now. So half the base is times the base is 6 and the height is 6.87 centimeter. So our answer would be centimeter squared. Our answer would be 20.6 centimeters squared to 1 decimal place, or 3 significant figures. And that's how you solve a problem like that. Thank you for watching this video. I hope it has been a lot of help. You can like us on Facebook at www.facebook.com/cmaths, or you can also watch more revision videos at www.cmaths.co.uk/revision videos. Thank you.